Assalamu alaikum students, welcome back with another video. Today we'll be solving another differential equation question, which is basically a 9-mark question. So you have to be very careful and cautious in such questions. You need to understand the step by step. I'll try to explain every step, which mostly the marking scheme does not cover. It's a very easy question, but you have to be very cautious. So let's start solving the question. The first thing that we will do is we have the differential equation. The first thing that we'll do is separate the variables. So we get all the x containing terms with dx, which means 2x squared, and k minus x cubed will be with dx, and 1 upon t will go with dt. So dt goes on that side, t goes on that side, it divides, and then I've just simply manipulated this equation and I've converted it into a form in which we can integrate. Now, after separating the variables, we are supposed to integrate both sides. I'll try to use different integrals because that helps a lot, especially when you have another unknown in the differential equation and you get plus c and then you make things difficult for yourself. So different integrals do help us a lot in such questions because we do not need a plus c with the different integrals. Observe closely what do I do with the different integrals. That will brush up your concepts of differential equation as well. And if you were unaware of this method, surely you can learn this through this question. Okay, so I'll integrate both sides. Here I'll say when x is 1, t is also 1. And when x is 2, t is 4. So now I have put the limits. I still need to integrate the entire thing. I know I can integrate 1 upon t. That will become ln t. But if I need to integrate 2x squared upon k minus x cubed, how will I integrate this? You see, if I have a cubic expression in the denominator, k minus x cubed, the derivative of this k minus x cubed is minus 3x squared. So only if I would have had minus 3x squared in the numerator, I would have been able to integrate it using ln. But I do not have that, so I'll have to manipulate it in a few steps. Let's see how do we do that. 2 is a constant. I can simply take it out. It is multiplying by the entire thing. I can just put it out. Now I need a minus 3 over here. If I multiply this by minus 3 and I divide this by minus 3 as well, this is how I can write it. And I have not entirely changed anything because these are constants being multiplied and divided, so they do not change anything in integration. Now I have it in a form in which I can integrate. The left side can be integrated as well, and so can the right side. Now be very careful with the steps. I'll say minus 2 upon 3 and ln of k minus x cubed is the integral, with the upper limit being 2 and the lower limit being 1, and ln of t is the other integral, with 4 being the upper limit, 1 being the lower limit. Now let's plug in the limits. Minus 2 upon 3 ln of k minus 2 cube minus ln of k minus 1 cube is equals to ln 4 minus ln 1. Okay, so now minus 2 upon 3 ln of, I'll take another step, ln of k minus 8 minus ln of k minus 1. And this should give me ln 4. I can just take this minus 2 upon 3. This 3 is dividing on this side. It will go and multiply. Minus 2 can divide. And I can write it as ln of k minus 8 upon k minus 1 is equals to minus 3 upon 2 ln of 4. Ln of k minus 8 upon k minus 1 is basically ln 4 to the power minus 3 upon 2. If I do 4 to the power minus 3 upon 2, that is simply 1 upon 8. So I can write it as ln of k minus 8 upon k minus 1 is equals to ln of 1 upon 8. Now both are single logs with single inputs. I can simply equate their inputs. I can say that k minus 8 upon k minus 1 is basically equal to 1 over 8. I'll cross multiply 8k minus 64 is k minus 1. 8k minus k is 64 minus 1. 7k is 63. And the value of k is 9. So once I've got to the value of k, I can proceed from there. I've already integrated it, but now I'll be using the variable limits. I'll be starting from this step. I'll just change the color of this to help you understand, because this is the part where I had integrated and I'll be starting from here. I'll say now the value of k is 9. The upper limit is x. Now when x is x, t is t. I'm using variable limits. I'll just take this minus 3 upon 2 on the other side because I need an expression for x in terms of t. So I'll write ln of 9 minus x cube, upper limit is x, minus ln of 9 minus 1 cube is equals to minus 3 upon 2 ln t minus ln1. ln1 we all know is 0. I am writing the left side as a single log. This is 9 minus x cube upon 8. And this is minus 3 upon 2 ln t. ln1 is just 0. So I can write this entire thing again as the power of t, that this is ln of t to the power minus 3. Obviously, you can write minus 3 upon 2 as minus 1.5 as well. Now, single log, single input, I can just say that 9 minus x cube upon 8 is t to the power minus 3 upon 2. Now, 9 minus x cube is 8t to the power minus 3 upon 2. And 9 minus 8t to the power minus 3 upon 2 is x cube. Now, in order to remove the cube, I'll cube root both sides, or I can write the cube root as a power of 1 upon 3. And this is my x. So now I've got the expression for x in terms of t. This is how we had to integrate this part. I'll also do the second part, which is just a 1 mark part. And the question says that state what happens to the value of x as t becomes very large. Now, large means infinity. I can write that x is, I'll just rewrite this, 9 minus 8 upon t to the power 3 upon 2. To the power 1 upon 3. So as t becomes infinity or very large, I'll write this entire thing. Infinity to the power infinity is infinity. And this will be infinity. Anything divided by infinity is 0. 8 upon infinity becomes 0. And x approaches 9 to the power 1 upon 3. This is the value that x approaches to as t becomes very large.